Okay. I hear an echo. Can people hear me? Do you hear the echo? Is there an echo, Aaron? I need to stop making changes. Is there an echo? No echo? Okay, good. Then it's properties, advanced properties, go XLR. Now I don't get an echo now. Good. No echo? Awesome. No echo. I was like, wait a minute. I don't have a microphone on. No microphone? You can't hear me. So you probably hear me touch the microphone now. It's great, right? So used to be, and I might go back to it. It was a good weekend. Had a good weekend. What did we played the new Mario Kart tracks. And so we played them on 150cc. And my wife immediately got first on every single one of them. Every single Mario Kart track. For some reason, I don't like that little boop right there in it. She got first on all Mario Kart tracks. First. Now, it's not 200cc, so we're going to have to go back and do mirror mode in 200cc, but we did the new Mario Kart tracks. We should do like Wiggler, the new characters. Wait, you ready? Ready? Tennessee won. My fantasy team mirror mode. Mirror mode's tough. You get used to the tracks, and then you got to go mirror mode on it. Let's throw out some U-Bot points. I don't think I can hear the music yet. Had it so I could hear the music, and then you guys could hear the music, and I've done so many different things. Now, can you hear the music? Wait, let me look. Do we do some work here? 1, 2, 1, 2, 1, 2, 1, 2. Oh, there's 2 Go XLRs? I'm gonna do something crazy. I'm gonna delete one of these Go XLRs. XLR. So I have 2 audio streams here. I deleted the world. Okay, you can hear me now. Okay, that Go XLR is not a thing. Okay, you can hear me now. I'm cleaning up this really quick. Okay. Okay, this is the Go XLR you can hear me on. Let's do audio. Good. Audio. Okay, it shows 2 Go XLRs, but I'm gonna ignore that. People are saying there's not an echo and the camera just randomly blurs. Let's go get some chapter 5 right here. How are people doing? Let me throw you another 100 points. Sorry about that. I'm trying to clean up the thing. I was doing some filming this weekend, and it actually was an echo, and I had to refilm 2 times. I filmed a 40-minute video 3 times because I had to refilm twice. So I'm glad there's no echo, but it's like the TV audio is captured by the Go XLR. So we're gonna do some percentile questions here. I think that's what people want to do. I want this to save the password. And save my password. So my Pearson. Good questions right there. Could you review the Canvas content, specifically questions about finding percentiles? What do you want to do, my Pearson or Canvas content? What do people want to do? And we'll get started here on some actual questions. Let's start a poll. My Pearson percentiles or Canvas content percentiles. So here's the poll right here. My Pearson percentiles or Canvas content percentiles. Take a vote right now and we'll do those. People are saying my Pearson. We might do some my Pearson percentiles. And I'd like to practice some that are similar to the exam. Yeah, we'll do those next probably. Okay, getting the my Pearson Canvas content's winning. People said it in the chat, so we are actually probably gonna do Canvas content and oh, it's literally 50-50. Take a quick vote. I'm gonna end the poll here in 5, 4, 3, 2, 1. Vote now. Is it literally 50-50? Canvas content tends to be relatively easy comparatively to CC. Maybe a little both. Yeah, let's do a little bit of both right here. Okay, so we're going to show how to do this. And let me go here to the apps. We're just going to start working through a whole bunch of these. So get ready. This is the apps page right here. Let's pin the message. Let's grab it. Okay. And we're going to talk about how to do this. And the first question we're going to do is the normal model IQ questions. Let's go over here, go to edit the video. Let's start this up. Okay. So this is the normal model IQ question. I'm going to take a quick note right here. We're at 733, Stat 201, Chapter 5, Part 2, normal model IQs. So with this right here, where do you want to go? Can anyone tell us where to go to solve these questions? Can anyone tell us where to go to solve these questions? We're going to do this the easy way and the hard way. So where do we go? We go to the applet. Now here's the thing, someone might be saying, how would I solve this on the exam if I didn't have the applet? I'm going to pull up Microsoft Word here in the background. And so I want to show you how you would solve this. The question stated to us, if you didn't see, that IQs are normally distributed with a mean of 100 and a standard deviation of 16. You draw your normal curve here, and how many standard deviations do you go now? You go up and down how many standard deviations? How many standard deviations do you go on the normal curve? How many standard deviations up and down? 3. Great job, Cameron, right there. So we are marking first the what's on the curve. What am I marking first here? The first thing I write on my curves is the what. The first thing I write on the curves is the what. The first thing I write on the curves are the what's, the z-scores. Then I put the context. The context is just adding the standard deviation to the mean each time. So when you do this right here, you're just adding and subtracting 16 from the number to go up or down that amount of standard deviations. So now we have the z-scores and the context. Now the first one said, I think it was above 80. Now if you look at above 80, I want you to take a look at it here. Let me add another pencil here to this. Above 80, those are pens, cool. Above 80 would be about at a z-score of what? Above 80 would be about at a z-score of what? If we were at 80, it'd be about at a z-score of what? About at a z-score of what? Close-ish, close to that. That'd be 78. So, or can you get me the exact z-score? So the exact z-score is going to be 80 minus 100. And good job on the negative right there, over 16. So I think it should be, double thinking it. Is it 1.33? Or is it 1.25? 1.25 rounded, right? Because one negative, when you not round it, it's negative 1.25, right? Am I drawing, is that correct? Yes, thank you so much everyone solving right there. So it should more accurately be right about here. Now here's the thing though, I've got a pretty good guess at this, and we would know that this area, just go with these drawings right now, has to be more than what? The area above here has to be more than what? How much area have I shaded in right now? This area above here, which is total the shading, has to be more than how much right here? How much is inside of there? I'm talking the total yellow area has to be more than what? This is how you would solve it on a test. And you might have to give an estimate or pick from possible values. Like we could give you like values like 60%, 70%, and has to be more than 68 because 68 is between -1 and +1. So it has to be more than, and that's the key right part right here, really? It has to be more than 68, and it also has to be more than the extra 16. Does anyone have a good guess? How did you know that the 80 is the left of the median? because when we go to the left, we go down, we subtract, because 100's at the center. So does that make sense, Reagan, right there? 100 was at the center, and then we start subtracting 16. So this 16 right here is the amount you go down each time or up right here. So you'd add right here, and you would subtract the other way down. Does that make sense? So maybe about 87%. 87%, good guess. So, and that's probably a pretty good guess right there. Like, yep, and thank you, Reagan, for asking. Let's start 100 points. Good questions. These are tougher things. So 87% would be a good guess on the exam. I'm going to go with, so it's going to be a little bit, let me think about this, a little bit less than that. I think it's going to be like, I'm going to go with 89.2 as a guess. Now, I'm just taking a guess right now, then we're going to show how to solve it. That's just a guess using what we could know on the test. So any answer close to that, do you get where I'm going with this? Like if this was the test, then the answer should be close to like 87-ish because it has to be more than 68 plus 16. So we know it has to be more than 84. And we've drawn it out here to show that there's more than, because this is 68, this is 16, and this is the extra that we haven't accounted for. So we're adding on a little bit extra right there. That's how we would do it if we had to guess on the test or use answers that are supplied to us. Now we want below 85, and this one we can take a pretty good guess at. This would be a very good test question where we'd have you get a very close answer to what it is, because I want you to look at where below 85 is. 85 is very close to a what of what? 85 is very close to a what of what? How some of the questions asked you for the margin to two decimal places in Norco. We might on the test. Yep. If you think something misgraded you on the test, please let us know. And great job. So if you think something misgraded you on the test, please let us know. We're nicer than my Pearson. You just have to say like, hey, I put this into one decimal or something. We're like, okay. So think about this. If we know that this is 68, then this is 16 because the outside, everything here has to add up to 100. So what are you thinking for an answer here, and theoretically why? What are you thinking for an answer for this one, and theoretically why? So we're asking, what is the yellow area? What percent of observations are less than 85? So what are we thinking as a theoretical possible answer for this, and why? We're asking, what is the percent of area shaded on the yellow part of the curve? And then why is that a good answer? So we know 16% is below -1. So what do we think is a possible theoretical answer to this? What I'm saying here is this is 16% of the curve. That is 16. Yeah, Reagan, great job right there, because it's a little bit more points for you, Reagan, right there. It's a little bit more than 16, right? So Reagan, let's try that answer. So Reagan, good answer. It's a little bit more than 16 because it's a little bit above that. So if we draw it out, we can say like that's a little bit more than 16, so 16.5, like 16, 17% as William is saying right there. And that's how we would do it on the test. And then an answer that you would get is possibly close to that. Between 116 and 136, so now we go to 116. Wow, look at this. Boom, right there. We're using green for that. 116 and 136, which is about here. So we're asking about this area. So how much, this uses the 68 rule a lot, how much is total from here over? Like how much yellow area is there? How much yellow area is there? How much yellow area is there? 16%. So our answer should be what? Because we're looking for the green area. Our answer is the green area. So our answer should be what to 16%? Because here's the 16% in the yellow. And so our answer should be less than that. So what are you thinking? I'm thinking like 14.2%, 14.4, something like that. And check answers. We got none of them right. Oh, we're pretty close to these, I think. If we adjust some decimals, we might get one of them right. I thought we were pretty close to some of them. Now we got one right. Okay, so let's see right here. 14. It might be that one. It might be 14.7. So we got one of these right by just taking guesses. So that's how we would do it on a test. We wouldn't have you find the exact. You'd need to probably draw it out, and then we'd give you multiple choice or something, but that's how it might look on the test. Now we're going to go to the applet, which is the pinned link above. I'll have MuBot say it again here, and the question becomes really easy. So what we can do right here is we're going to pull up the applet. I'm going to find the screen down here. We're going to go over to the applet, and we're going to enter in a mean of 100 and a standard deviation of 16. Then we're going to go to find the p-value or probability using x, and then we're going to enter in above 80, I think it was. And then we're going to go into 1 decimal. So the first one is 89.4. Monster Man right there. So 89.4. Does everyone see this? We have a mean of 100, standard deviation of 16, and above 80 is 89.4, which looked like our first drawing if you rewind the tape right there. So the first answer is 89.4. I think we were closer, and it's over 80. Next one is under 85. So now we go here to below and go to 85, and it's 17.4. So we were close. We were pretty close to these. You just have to be accurate. And then we get the last one correct. We did get the last one correct. Reagan, another 100 points. Your 40, or Aaron right there, that 14.5 was really close, between 116 and 136. So we go over here and we go between 116 and 136, and there is the 14.6. Aaron, you would have guessed that one. Your answer right there is close enough. Yep, you were close enough that you would have got it right with 14.5. That would have got it right. So you would have guessed it, 14.675. But if you said 14.5%, you would have guessed it. You'd be like, it's a little bit less than 16, 14.5%. You got it. So make sure to try to do these drawings. That's where you really learn how to do the curve, and you know what you're looking for when you make the graphics. So if you look at each of those graphics we made, it looks like the curve we draw. And that's what the point is like the applet is just finding the exact answer where we can kind of estimate using the empirical rule. I'm going to do another one like these, then we might hop over to Canvas content. We did the football one in a different class. Gosh, I read it. Let me find another one of those, because I like the percentage questions. Can we do the Virginia Corporation? Sure, let's find out about those steers. Let's find out about those steers. The Virginia Corporation doing steer research. Likely approximately half of the intervals. When it is exam time, we have to scrap paper. Yes, you can scrap paper. More percentage questions, you bet. Oh my gosh, it's blocking the screen. IQ tests. Where's that Virginia Corporation one? 53 men. It's on. It's going to be the last one. It's on here, right? The Virginia Corporation extension. Is it? Did I pass it? Does anyone see this one? I've done the steer one before. Do you see it on? There's steer weights. You want me to do this steer weight one here? Is that okay with you, Sarah? There's this steer weight one right here that does percentiles. It's on the homework. We can do the homework next. This should be pretty similar. Tell me if you want me to do it afterwards. This one will be pretty similar to it right here. It even asks the IQR, which a lot of people get stuck on that one. Let me know. I'm going to put the timestamp. And let's do this one. Chapter 5, Pop 2. And we have here normal model steers. You're welcome right there, Sarah. So we have normal model steers. Okay. With this right here, we need to turn the percentile into an observation. Let's do some quick guesses of this. We're just going to do some quick guesses, and then we're going to see how to get the answers. So what is the mean of this model? Know how to read this up here at the top of the screen. Let me take a screenshot of this. Know how to read this at the very top of the screen. What is the mean of the model, which is the center of the curve? What is the mean of the model? There you go right there, Cameron, great work. The mean of the model is, here we go. Ooh. There we go. The mean of the model is here, that's the mean. And this is the standard deviation over here. So the standard deviation is the second number, and we sometimes write these as mu and sigma. Worst mu I've ever written. Mu and sigma. It's like making the bar go away. Maybe if I double tap again. There we go. Now I think it's always on here, which I like. Okay, so this is mu, and this is sigma, and that is the mean right there. Aaron is on top of it. More points for Aaron right there. Great work. So, and just keep answering and asking questions. So now I want us to think here theoretically about this. This is just theoretically, and this is a good theory thing. We're going to go with an easy concept here. Percentiles go from what to what on the curve. This is an easier review of this concept, and we're going to get the answers. Percentiles from left to right go what to what on the curve. Like from the lowest portion of the curve to the highest portion, from left to right, percentiles go from what to what. And like, what would be the lowest percentile? You're on track with it right there. And what is the lowest percentile on the curve? They go from left to right, and the lowest percentile would be 0 to 100. Great job, Reagan, right there. 0 to 100. So the 100th percentile is literally the highest point possible, the highest observation. The 0th percentile is the lowest percentile. And right here at the middle at 1127 is the 50th percentile. So we're just going to go a little bit theoretical here. And we know 3 standard deviations is the very top of the curve. Where do you think the 59th percentile is? We're not going super like trying to figure this one out. I could go way into detail, but we're going a simple concept for now. Where do you think the 59th percentile is? Just a guess. Just like, where do you think the 59th percentile would be mathematically? Just a simple idea for this. Let's not find the exact answer. Let's just go, the 59th percentile is kind of here-ish. Where's the 59th percentile at? We're not going too in depth. Where would the 59th percentile be? A little bit to the right of the center of the curve, right? So maybe about there. Sounds about good, right? Where would the 94th percentile be? Where would the 94th percentile be? Great job right there, Reagan and everyone. Where would the 94th percentile be? It's actually between standard deviations 1 and 2. Like, who wouldn't think that? It'd be way over here. What does it mean to be at the 94th percentile? If you're at the 94th percentile, what does that mean? 94% of observations are what to you? So closer to the 100, right? It's actually further away than you would think, just because 100th goes way off the curve. It's like way, way beyond the curve. But 94th percentile means 94% of observations are below you. 94% of observations are below you. So probably right here, I'm going to take some guesses at these answers. Let's see if I can get any correct just by guessing them. So once again, Brian is just guessing right here. You're not really meant to do this. But also I want to point something out right here. When we draw the curve, we usually only draw it to how many standard deviations? Like all the way to the edge of the curve is usually how many standard deviations again? Which this should be right about. That's not purposely to scale. When you draw the full curve, and the thing is 0 and 100% are off the curve. This is not properly drawn to scale at this time because the very edge of the curve would actually be the 99.85th if we only go 3 standard deviations. And the very bottom of the curve would be the 0.15th. And why is that? That is because 3 standard deviations only shows you the middle what? 3 standard deviations only shows you the middle what percent? So I'm saying the very edge is not 100 right here because we're not to the very edge of the curve because it goes on endlessly. It only, not the middle 50. That's the last question right there. But plus or minus, and Reagan has it right there, 99.7 when you go plus or minus 3 standard deviations. So technically down here at the bottom, the way we've drawn it right now, this down here on the bottom is the 0.15th percentile right there. And this is the 90, blocking it. This is the 99.85th percentile. Do people follow this? That's the 0.15th percentile, and that's the 99.85th. No worries, Cameron, right there. Good work. But it's basically the 100th percentile would be even further over than that. So I'm going to take some guesses here. Then we're going to show how to get these answers. So the 59th percentile, 1147. The 94th, these are hard to guess. These are pretty darn hard to guess. The 94th percentile, 1252. And the IQR, let's go 101. Check answers. We got one correct, and it's probably the IQR. The IQR. I know how to do that one. So we got one of these correct. For that 99.8, we need to place to memorize on the exam. Yeah, yes, you would need to know that because you subtract out the outside and you get 0.3 on either side. So you do need to know that one to 2 decimals. 99.85 is the percentile at the third standard deviation above the curve, and then below the curve at the bottom is the 0.15 standard deviation. So with this right here, now we go to the applet. We should have some decent guesses at this. But also here's what I want to point out, is that what you're going to see right here, let me put this over here and put the applet on the other side of the screen. And so now take a look. When I do this, I want you to see, and let me disappear so you can see it, that what I show you is where my lines are. So here we go. A mean of 1127, standard deviation of 75, and then we go here. We are going to find the x value using the percent. So now we're going to go to below. When we do prob for the night, oh, did you get it right, Aaron? Nice job, Aaron. The 59th percentile is, and we can round it to 1 decimal, which is great. Thank you, Adam Spanbauer, for writing this applet. So the 59th percentile is 1144. We'll put that in the chat to remember it. The 94th percentile, if we go here to 94, percentile is always below. And I want to point this out really quick. Does it look kind of where I put this green line? Do you see the green line right there? That's where the green line is kind of at right here, a little bit higher than the bump right there. The 94th percentile is over here, and that should look about where I put that line right there. So just with my knowledge of using the curve multiple times, I know the 94th percentile is there, and that's because, if you're wondering how I knew that, this is the 97.5th percentile, because 2.5% is on either side, because this is the middle 95%. So I used that knowledge right there. Oh, you were close. You guessed what? 1265, and it's all 44, 1144, and then 1244. How close was I? Was I pretty close on my guesses? Oh, there it is right there. I was a little bit off. I was off by 3, and I was off by more right there. So that should do it for the answers. The IQR is going to be the middle 50%. So if you go here to 50% and go between, you would just do what to these two numbers right here? Oh yeah, so yep. And so you go a little bit below the second standard deviation. So it's somewhere a little bit below the second standard deviation. And this is Q1 and this is Q3, because that's where the start of the IQR is, Q1 to Q3. So all we're going to do right here is subtract these numbers. So let me go ahead and pull up the calculator, subtract the numbers. And we go here to calculator. And we go 1177.59 minus 1076.41. And we get right there 101. I also know a trick that the IQR is about 1 1/3 of the standard deviations, because I know the z-score of it is like 0.674, I think it is. Let me go look at the z-scores. I think I know the z-scores is 0.674. There it is right there. So that's how I was able to solve it, is I know the z-score, and then you just round up a little bit because it's not exactly 2/3. It's funny that the IQR, which is the middle 50%, has a z-score that's close to 2/3, and that's how I keep it in my head. But since I knew the z-score, I just used the z-score to then figure out the answer. You're not meant to memorize the z-score. You're meant to know things like the IQR is the middle 50%. So for a question like this, how can you find the exact answer without the applet? That's why we have the applet. So, and also, there's actually the applet for your phone. It's probability distribution by Matt Bogner. So if you can't see right here, I have the normal curve on my phone, so you can kind of see it right there at that angle. There's the normal curve on my phone, but then we have the empirical rule if we want to solve these without using an applet. So the empirical rule is the knowledge that we always carry with us at all times, the 68, 95, 99.7, and then the applet allows us to get exact answers, and we can also use things like code to integrate the curve, or you can use calculus. But in understanding of how the curve works, put it this way, Aaron, were my guesses kind of close? Were my guesses kind of close? I had 1152 here, and this is without using the applet. Was I kind of close? So the exam would want you to understand how to draw the curve and how to get kind of close. And then we might give you multiple choice for the right answer. So you'd be like, oh, I'm thinking it's about 1147. So 1144. And we put answers that are completely implausible. So if you have no idea what you're doing, you have no idea how to do it. But we would give answers that would be either obvious or like obviously right or obviously wrong. So we wouldn't put an answer like the choices wouldn't be 1147, 1146, 1145. We'd put something like 1280 or like, 1080. It'd be answers that are obviously wrong because they're on the wrong side of the curve. Like it would be like the 59th percentile, but the answer's below the mean. So the 59th percentile has to be above the mean. So you can usually logically deduce it, and if you have a good guess, you'll know which one it is. So we don't expect you to get the exact answer by like calculating it. We expect you to maybe draw the curve and then be like, oh, well, the answer has to be above the mean and between z-score of 0 and 1, so it has to be here. And so the more you know the empirical rule, the more you can solve questions like that. And maybe we'll do one more of these, and then we'll jump to Canvas content. So which one should we do next, or should we go to Canvas content? First person who says it, we do it. If you say like, do this one, or if you say do Canvas content. Yeah, so it's basically being able to draw the curve, knowing how to solve things with the curve is key. Steers. Oh, the homework one? The steers was first. Steers from the homework I think we're doing. We're gonna do the homework steer question right here. The homework was the first answer, and my chat can look a little different. So Sarah was first right there. I'm always afraid. One time I used to do like first person to answer wins points, and then the chat actually looks a little different on your side because if you chat, it often shows your chat first because Google does or YouTube does a little bit of like checking to make sure everyone's nice. But I've had people be like, wait, I was first, and then I'm like, and then I showed them on the chat on the screen. I'm like, no, I'm not. I swear I'm not being mean. Is the first question? Here we go. Here we go, the Virginia Corporate Extension. Okay. Let's go do this one right here. And 33, 55, stat 201, chapter 5, part 2, the Virginia Cooperative Extension. Okay, here we go. Then we'll do Canvas content right after Reagan. Okay, we're gonna take guesses at this to begin with. So we're just taking guesses. Are you ready? I want your help to take guesses at this. What is the mean of the data? Just tell me the mean and the standard deviation. The mean and the standard deviation. The mean and the standard deviation. So I'm gonna do it a little higher level. The mean and the standard deviation. Tell me them in the chat. Mean, standard deviation. Now, what should you do to really get good at these? As soon as you have the mean and standard deviation, if you are practicing these, draw your curve. Does that make sense? Draw your curve. So take a moment right now. You could actually go in here. You can actually keep the z-scores down below and draw. You know what? I guess we should do it. Take a moment, draw the curve here. We're actually going to do it. I was going to do it in our heads, but better if we do it on paper. 1152, and then 84. The z-scores never change, so 115. I'm going to do this. Now, what is Brian doing with his numbers? Just to make his life easy, don't do this. What is Brian doing just for concept teaching to make his life easy? Makes it a lot easier. Man, why don't they do this for every problem? I guess you gotta know how to handle numbers that are not like this. Just rounding it. Is this gonna be the exact answers to the problem? Is this gonna be the exact answers? No. We're just rounding it for the moment for example purposes. Here are your exact numbers up there. And now let's take a look at our problem and think about this. You ready? So now, let me put both things on the screen at the same time here. So we're going to put both problems, or our graph on the screen and the problem. The percent of steers over 1250. So 1250 looks to have a z-score closest to what? Here's 1250. 1250 looks to have a z-score closest to what? 1250 looks to have a z-score close to what? The z-score of 1250 looks to have a z-score close to what? It might be 1.5, maybe like 1.2, 1.3, in that range right there. Good, Cameron and William, great answers, more points. And so here's the thing, is the area has to be a little bit less than what? The area has to be a little bit less than what? So now, visually speaking, and this is how you do it on a test, because we'd give you answers like 20%, 24%, 30%, and then the answer has to be a little bit less than, you'd only have one answer that's plausible here, a little bit less than 16. So that's, if people keep saying, well, how would you do this on the test? There'd only be one answer that would be less than 16, because you know, due to the 68 empirical rule number, that it has to be less than 16. So a good guess right here, and we get 2 guesses for free. Let's go with 14.2, that's wrong. It falls off quickly when it's there, so let's go with 13.4. Nope. So now we have to go to the applet. You have to go to the applet to solve these to get the exact answer. So the mean of the curve is 1152, the standard deviation is 84, and we are finding the p-value or probability using the x value, and we're going above, was it 1250? And it's 12.2. 12.2. Does that look similar to our drawing? I'd say so. I'd say pretty similar. Not perfect, but pretty similar. So we got close, but not perfect. Good. Now the next one right here says under 1200. Now we can actually keep the lines on the curve, and under 1200 would be about right here. So that has to be a little bit less than what? I'm trying to think. I think I have a good guess at it. That has to be a little bit less than what amount? I'll give you a hint. Or it's a good bit less than it. A good bit less than what amount? A good bit less, because we're only saying below the blue line. Below the blue line. So below the blue line should be what? Below the blue line. So the total shaded in is 84, but below the blue line has to be less than 84, and it's probably close to about that. Darn, I want to get one of these right by guessing. Well, we didn't get it right by guessing. But now, when we go over here to the applet, we should have a picture that looks very close to it, and that should look very much like it. It was 71.6. Are people following along? Give me a yes or no in the chat. Your picture that you draw should look something like you get with the applet. So you want to draw a picture and be like, well, it's got to be a little bit less than 84. And I should have did a good bit more. William's got it right there. So these are tricky questions. 71.6 is the right answer. Wasn't close enough, but we'd put something like 90 on the test. We'd put answers that are obviously wrong, and then there's only one right answer. Between 1,000, yeah, don't worry. Oh, I'm not. Some days I get them all right, and people are like, how are you doing this? But today is a day where I'm only getting a few right by guessing. Between 1,000 and take some guesses at this. Ooh, I think we can do a pretty good guess at this. I think we can do a pretty good guess at this. This one, they gave us some nice numbers. Now, I did round my numbers, so maybe it's not really good. But think about this. We know that below here is 16% due to the 68 in the center, and then 16% outside. And we know below here is 2.5 due to the 95 in the middle. And then the 2.5 on either side. So what's a good guess for this? 13.5, yep, classic number for that percent right there. 13.5 will be pretty close. Ah, we didn't get it. Let's go. I don't know which way it's gonna go. Well, it was a good guess. That's exactly what I would guess right there for that one. Is that the applet? Looks like the applet. There we go. So we're gonna go between and 1,000. Oops, that's not 1,000. And was it 1070? No, 1080. I think so. Really? 16%? Well, my drawing is not perfect. Remember, I did all this rounding. Let me look at the numbers again to make sure. Oh, 1075, 1075. It's going to cut off a good bit. 14.5, 14.5, 14.4 when rounded, because there's extra digits. So 14.4. So 13.5 was a good guess. You were only off by 1%. Let's throw you 100 points to that, William. William, your answer was only off by 1%. You're like, 13.5, and it's like, it's 14.4. Not even 1%. You were that close that you're like, it's about 13.5% of the curve. Good guess right there, so you're pretty good at it. Cameron said 14%-ish. Gotta throw Cameron more points for that. So Cameron, it's 14%-ish. I mean, it is 14.4%, so Cameron, you were right. And yeah, you're pretty good at guessing. You just look at it, you're like, it's about 13.5 according to the normal curve, so 14%-ish. Okay, let's do Canvas content next right here. Go to the main screen. These questions take practice, and you want to draw your normal curve. Close but no cigar. Well, you were closer than me. Got some good guesses right there. These questions take practice. I can't state that enough, that you have to practice these. They're not questions that you just know how to do without doing them multiple times. Got to one, Canvas content, normal curve. Oh, I'm not even logged in. Definitely just going to practice. Yeah, the whole entire NC. Wait, what? Oh, normal curve. I thought I was talking about like NC State or something like that. We did that in high school. That helped me tremendously. What helped you in high school? I'm gonna practice making the whole entire, drawing the whole entire normal curve. It really does help to draw it out. And that's what we say, draw it out. So draw out the normal curve, practice drawing it, know what it looks like, be able to show the numbers on it. And that's where you really get it down and know the percentages. Can you do the journal? Yeah, is that on Canvas content, Reagan? I'm pulling up Canvas content now. Want my input? No input. Normal curve, all their percentages in different places is big thing right there. I'm gonna pull up a version of the Canvas content. Let's hope, we'll cross our fingers that it has it. So we're gonna go here and do the Canvas content. Has anyone gotten the homework done or the quiz done while they've been here? That was my goal. Chapter 5, Canvas content. Okay. Let's go over to the main screen. Do it. Timestamp this really quick because I spent a little bit longer on that than I wanted to. So we're at 44.3. And here we go. Okay. A 1992 journal article said that adults have a body temperature of 98.2 and a standard deviation of 0.07. The outside area on this curve is shown. And so the first thing I would do, I would go here and I would take a picture of this and I'd mark it. If I had my test, I would immediately start drawing. What number is Brian going to write on the screen? Here. What number is Brian going to write on the screen right there? Use the information above and tell me what number Brian is going to write on the screen right there. Not 2.5. Good guess. Not 2.5. So here's the hint. What number will I write right there? What number will I write? Boom. So I can write 13% or 0.13. That's the shaded area. I've circled the shaded area. Now, what numbers will Brian write below here and here respectively? What number will Brian write? Yep, Cameron, you got it correct. Cameron, you got points right there. Good job. What number will Brian write below there and there respectively? This is using we start marking down the information we have and we go from there. We're not even reading the question or what they want us to do. We're just writing the information down on the curve so we can translate it to knowledge and then use that knowledge to get the answer. The temps, exactly. So these are the values seen here and here. We're just going to take those values and display them below on the curve. So we have 97.14 and 99.26. And then the question asks, what percent of adults have a body temperature above this? So think about what we're looking for. And who here can now see the answer and be like, yeah. Like, that's hot. I mean, it is hot, higher temperature. So think about what you have right here, and I'll give you a hint. This is symmetric This is the middle 87%, because 13% is on the outside. So does anyone see how to get the answer to this? You got it, Cameron? Because we just take 13, divide it in half, because it's symmetric. So we go right there, divide it in half, and that's going to be the answer to the question, and that's it. What's it want in decimal? Or it says report like this, so 6.5. Does that make sense? It's like once you see it, you're like, oh, it's 13% on either side. We're at that point over there. We just go above it, and half of the 13, okay, it's 6.5. I'm done. There you go. That's how we do it on the test. We'd ask you something like, like what percent of people have a body temperature above this? We can give you a picture of the applet, and they have to know what you're seeing, and writing down the information can really help with those. A z-score is this. Jerry got that. What's his z-score? Yeah, no worries right there. Good answer. So what is Jerry's z-score? Well, did Jerry score above or below the mean? That's the first thing to realize. Jerry got a mean, and I'll screenshot and I'll start drawing on this, because we should know how to mark everything. I'll write down the full problem. I'm not here to just give answers. I want you to see how to do it. 1.33, Reagan, points for you right there. That is correct. So the first thing you do is you mark your notation. The mean is mu, the standard deviation is sigma, the observation is y, which is what we observe someone getting. A z-score is equal to the observation minus the mean over the standard deviation, observation of 78, and that's how far someone is from the mean. This is in terms of standard deviations, and so the answer is equal to Jerry scored 1.33 standard deviations above the mean. Smarty pants right there, making a 78 on the exam, worth some 50 points. So good job, Andrew. Oh, should we put an Andrew Tate quote? Is that too spicy? Is that too an Andrew Tate quote of the day? Oh man. Oh man, that's too funny. I like that. Let me throw 100 points for cracking me up at least. We'll throw 100 points. So I try to stay away from all the spicy topics in this class. We are muy picante. No tengo spice. No lo tengo. So, okay, I'll take it. Oh man. And I don't talk about social issues. I don't talk about a lot. I don't talk about here. Okay, no comment. The finish times of a local 5K race, I think it's 3.12. I think it's 3.12. It's not 3.14 like pi though. Are the following: a mean of 25 with a standard deviation of 3. First thing you're going to do if you see a question like this is mark your what. We just said it a second ago, start marking your what. Start marking your what. Start marking your what. Start marking your what. The mean, the standard deviation, the notation, get it marked, get it good. Does anyone know the answer to this one like that? Who knows the answer? I do know the answer right now because I know the z-score right now. Does anyone know the percent of finishers we'd expect using the empirical rule? Hint, hint, hint. Not 95, but above 31 minutes. Does anyone know the answer as I draw how to get the answer? You've done a lot of these. You look at this problem and you know the answer. Not 2, very close. Carry the decimals, very close. The z-score is 2. I think that's William, good answer right there. Let me throw you some points. The z-score is 2. So you are correct about the z-score. That is the z-score because we're going to put the context below the curve. The context is a mean of 25, and then you go up, and there's 31 right there. So that's actually all we need to write. So it is a z-score of 2, but within here is the middle 95, meaning that outside of here or above here is what percent? So what is the percent above there? So we're saying what percent of runners do you expect to be above 31 minutes? And the answer is what? Now you have to make sure you can't put, there's a lot of wrong answers for this, but you want to do the outside of 95 on one side of the curve, and it is what? The outside of 95 on one side of the curve. 2.5, great job, William, right there. Yep. And then you know you've got it correct if it adds up to 100% on both sides, or when you go across the whole curve. So good question right there. Really good practice. How does a normal probability plot tell you if something's normal? So a lot of good stuff right here. Let me make sure I got R up and going. I might show this today in class too. Okay, so a normal probability plot. And this is a good review because people forget this all the time. Okay, if it's one standard deviation below 22 minutes, yep, 16. Great job, Aaron, right there. Throw some points. You're free to ask those things. You are correct. Below a z-score of -1 is 16%. I've done a lot of these. So here is random normal data. You're not meant to know how to code this, but this is 100 observations that are random normal. And here is a normal quantile plot of this, and this is normal data. What do I mean by normal data? I mean the data would follow the normal curve, even though it doesn't look like that. That is a normal curve. Sometimes you just don't have enough data points to make it look really normal. So let's add 1,000 in, and there's the data. And here's the QQ plot for it, which follows the red line mostly. Good to see you here, Hannah. So what you can do is you can go right here and change this to an exponential distribution, which an exponential distribution is a right-skewed monster man. Now it doesn't follow the normal. This is a review of the concept. When you make a normal probability plot, if it is normal, it's going to follow. You know what? Let's call this Y so we can show both at the same time. So monster man in the chat. So that is a skewed or not normal. You've got the guy blowing it to the right there. You think about it because it goes like, you know, and it's skewed to the right. We drew that in class right there. And so that is a right skewed histogram. Monster man right here. If I was monster man, my tail back there, monster man. I like monster man. I don't know what I'm doing today. And so right skewed monster man. And then this is a normal distribution right here. And so the normal distribution right there with a QQ plot or normal probability plot that follows it. Yeah, the Squidward drawing from class. And here's the last thing you should know about this. If you do a normal goodness of fit test, the goodness of fit test comes back with a high p-value for the one that is normal, and the Shapiro, the goodness of fit test, also known as Shapiro-Wilk, comes back for a low, oh, I put the wrong thing in there, comes back for a low p-value for the not normal one. That is a very small p-value there, 0.00000000. Review this. A lot of people forget this for the test. And the good thing to remember is a normal probability plot, read it backwards, is a plot that tells you the probability of it being normal. And the way it does that is if the data follows the straight line, so the line is straight or the data follows the straight line, and if the p-value is high, that is a goodness of fit test, not a normal probability plot, which is a plot that tells us probability of normal. The Chocolate Boom company manufactures many types of candies. They have a mean of this and standard deviation of this. You decide to buy a box of candy. Your box is this much. Calculate the z-score. Your box is above or below weight. Your box is above or below weight. Look at your box. Your box is above or below weight, the average weight. Your box is above or below the average weight. It's below. If it's below, the z-score must be what? If it's below, the z-score must be what? We'll do one more version of Canvas content, then we'll go to class. If it's below, it must be what? If it is below, it must be what? Negative. Great job, Reagan, right there. And amazing work, Reagan. I'm hoping it makes more sense right here. We've done a lot of examples today. It's really, this is a chapter where you have to practice it. If you start this chapter the night before, you're going to have a bad time. Because you're going to be like, oh my gosh, what did I do? That's about negative 0.67 or so, I think. Negative 0.68. I didn't throw on the negative, but negative 0.68. I think we should be good. I think we should get it all correct. Hopefully, cross your fingers. Sometimes I miss one. There we go. But let's do one more version of this right here. There are other versions, and you may have seen me do them online. Thinking getting better. Yeah, it really, you'll start to be like, oh, these are easy. So we don't have much time. I'm going to do this one fast, okay? This is speed running the Canvas content. Do I have that here? I used to have it. Wrong thing. Man. Well, darn. Wait. 2 seconds. It'll be worth it. Thought I added it in. No. Okay, it's not there. Okay, good morning, Jennifer. Good to see you here. We're going to speed run this right here. So this is going to go a little quick. Then we're going to take a break before class. So let me timestamp this. Apparently, I don't have the speed run screen. I do have a speed run timer. I don't even have that installed on this. Okay, stat to 1, canvas, content, speed run. Okay, we don't have the timer, but ready? Start a timer.
For how long?
Start a stopwatch. Here we go. 3, 2, 1, let's go. We are speedrunning this here. Check out the earlier version where we went slower. So what percent of runners should be below 22 minutes? That's 1 standard deviation below the mean, 16%. How does normal probability plot tell us if it's normal? It follows a straight line. The data points do. We have right here the middle 80%. So we'd want to know where someone is at. If they're at the 80th percentile, this is the middle 60%. So the 80th percentile is right here on the curve. So since that's the 80th percentile, it has a z-score of 0.842, which we times up by the standard deviation. We add that to the mean, and we get the following right there. There it is, right there is the answer. How many decimals? 1 decimal. Round that to 1 decimal. Good to go. Taco Boom Candy Company, that is a little bit above the mean. It's about 15 above the mean. So z-score is going to be about 15 divided by 23 point this, about 0.7. There we go. 0.6 right there. 2 decimals, 4. And above that right there, that's going to be 2.5. And did we do it? Stop the time. I think we might have done it in under 1 minute. Sub 1 minute. Sub 1 minute right there. Speed run it right there. Under 1 minute. Speed run debuff, no long hair. Oh, that's a debuff, is it? This is speed run category, no long hair. Medium length hair, Brian. But that's got it for now. We're going to come back here shortly. There's more time to do this, more office hours tomorrow. Maybe I'll even try to stream tomorrow. I think what I'm doing tomorrow, but maybe I'll do a surprise stream. Maybe I'll do more streams in the afternoon too. How we did the 80th percentile one. So with the 80th percentile one, yeah, I'll see it right before we leave. So take, what are you seeing on the screen? On the screen right now is the middle 60%. So what percent is total outside the curve? So if this is the middle 60, what percent is total outside the curve? So if this is the middle 60, what percent is total outside the curve? 40% outside, you're welcome. And so this is 60% inside, leaving 20% here. Where is the 80th percentile? Where is the 80th percentile? The 80th percentile would be where blank percent of the data is where to that. The 80th percentile would be where blank percent of the data is where to that. The 80th percentile would be where 80% of the data is, or you could say, do the other side of it. The 80th percentile is where? And at a z-score of 1, it's the 84th percentile. Below, exactly, 80% of the data is below that. What do we know of the 80th percentile? We now know the what of the 80th percentile. We now know the what, and I just highlighted it right there. We know the what of the 80th percentile. We know the what of the 80th percentile, the z-score. And a z-score tells you how many standard deviations you are above or below the mean, right? So if we know the z-score of the 80th percentile, well, then we go to the mean of 98.2, which was given to us. I also wrote it up there so you could see it. And then we go this many standard deviations above the mean. So the z-score tells you how many standard deviations above the mean you're going. So that last part right there, the z-score, we take that and we just go that many standard deviations above the mean. Does that make sense? This is a tougher question. And also drawing the numbers on the curve can help, because if you know this is the spot you are looking for, your answer has to be between these numbers. Your answers would have to be between, and what would be a good logical guess right here? Like if you drew this right here, what could you logically guess? Like you might guess about what to 1 decimal. Yeah, so and this is like if you draw that, then you'd be like, well, it has to be between 98.2 and 98.9, and it's way closer to 98.9, so it's somewhere in there, right? And then if you do the exact mathematics, you get, I think that's the last one I did on the screen, you get, or I'll do the exact math over here again. If you go 98.2, well, we gotta go away. This is a tougher one. And great job following along, because I did do it really quickly even doing this. And this is where, if you had the applet, you could just cheat and go to the applet and be like, okay, you go right here and you go a mean of 98.2, standard deviation of 0.7, and then we are finding the x using the percent, and we want the 80th percentile right there, and it'd be below, and there it is right there, and we go to 1 decimal, and there's the answer right there. Yep. So once again, this looks a lot like our drawing, and this is what you want to do, and I'm glad it makes a lot of sense, because this was a tougher question, and if you understood it, you're doing great. Well, until then, bye for now, everyone. Bye.